We are taking chapter number 5, Minerals and Energy Resources. Minerals and energy resources, specifically we'll talk about the Indian minerals and energy resources. So it starts from a story that Haban, he is from Guwahati. He came with his father to a place where he witnesses certain kitchen, and the kitchen is moving. So he is surprised. He asked his father that how is it possible? The father replies that these are not made of bricks and stones. These are movable iron and aluminium, and it works with engine, that is the energy to work. So this aluminium and iron, we'll find it almost everywhere. It is everywhere. So minerals are what? The minerals, they are naturally occurring substances that have definite internal structure. So if you say that this is a mineral, so it may contain say X% of something, Y% of something, or Z% of something. That is say 20% here, 30% here, and 50% here. So this is a specific kind of mineral which is having a definite internal structure. It can be chemical differently or physical differently. So they are found in various forms, and they are used for variety of purposes like diamond, the limestone, fluoride, and aluminium. And if I can tell you that right from a needle to the airplane, we will find different type of minerals being used. Even the human body, even we use the mineral in different form of way. Apart from this, I can just give you an example that the toothpaste you use, like toothpaste cleans your teeth, and we have abrasive minerals like silica, limestone, aluminium oxide, and various phosphate, and that do the cleaning. To reduce the cavities, we have fluoride, which comes from mineral fluoride. Then we have titanium oxide, most toothpaste, and we have different minerals in it like rutile, ilmenite, and anatase. The sparkling comes from the mica, abrak. So this is, and also the outer covering and the internal ones, means outer covering is of course coming from plastics, that is coming from petroleum. So a simple toothpaste which we use in the morning is having a lot of minerals. So rocks, what are rocks? They are combination of minerals along with impurities. So we have minerals along with certain impurities. So we need to clear these impurities to get the minerals from these rocks. So a rock can contain either a single mineral or it can be a combination of a mineral. Then ores, an accumulation of any mineral mixed with elements. An accumulation of any mineral mixed with elements, that means one element, two element, number of elements, if they are mixed and we have a proper mineral which we want in it, they are called as ores. So they are the source of minerals because we are extracting, minerals are extracted from their ores, and there are different processes which we generally employ. Let me just give you an idea of classification of minerals. Like it can be metallic, it can be non-metallic, and it can be energy minerals. So metallic, that means they have certain properties, like they are malleable, they can be put in sheet, they are ductile, you can have wires, you can make wires out of it. They are lustrous, that means they sparkle, they will shine, and they have good electrical and they're electrical, and they're good conductor of electricity, and they're good conductor of heat also. So these are metallic. Then we have those elements which are not metallic, that is the properties I just told you, they don't follow or they don't show. So these are non-metallic. And then we have minerals which are energy producing, they produce energy. So in metallic, we have ferrous, non-ferrous, and precious. In ferrous means, see, ferrous has come from the Fe word, this ferrous. Ferrous means iron. Ferrous, Fe is iron. So ferrous, that means containing Fe, iron. So metallic, the other category in metallic is ferrous, that is iron ore, manganese, nickel and cobalt. So iron ore, manganese, nickel and cobalt, they have quantities of Fe, iron. Then we have non-ferrous, that is not having that much quantity or no quantity of Fe or iron. We have copper, lead, tin, bauxite. Copper is tamba. Then in the metallic category only, we have precious metals like gold, silver, platinum. When we come to non-metallic, we have mica, salt, potash, sulfur, granite, limestone, marble, sandstone, etc. The energy producing minerals that we know very well, like coal, petroleum and natural gas. So where do these minerals occur? They occur in igneous and metamorphic rocks. They occur in sedimentary rocks. They occur in the deposition of surface rocks, in the sand of valleys and in oceans. So let us see them one by one. In igneous and metamorphic rocks, so they are found in cracks, crevices, the fault and joints called veins and lodes. For example, zinc, copper and lead are found here. In the sedimentary rock, the bed and layers as a result of different deposition and accumulation of different layers. So coal, iron, gypsum and sodium are found here. Then decomposition of surface rocks in the form of residual mass containing ores after decomposition take place. So if we find bauxite in these areas. Then in sand of valleys, especially the precious stones we find here. So an alluvial deposits of different rivers, different, the base of mountain. So this is called, these are alluvial deposits called placer deposit. They are called as placer deposit. For example, precious stones like gold, silver and tin and platinum are found here. In ocean also, we have different minerals in the diffuse form like the salt, the manganese and bromine. So what is the distribution of minerals in India? The petroleum deposit, I'll show you this in the map also, but just to know that the petroleum deposits are in Gujarat and Assam. The non-ferrous minerals we find generally in the Rajasthan area, and the coal, metallic minerals and non-metallic minerals are found in the peninsular plateau. So what is a mine? Mine, you cannot say anything as a mine until it's a large area having an abundant quantity of mineral deposits that can be easily and economically extracted. So say if this is a coast and you go say 1000 kilometer here and you put a lot of effort and you get a very little amount of mineral, and then the cost is also very high if you want to sell it, then there is no point in calling it as a mine or working out it as a mine. But if you have a place here, you have some industries here, this can be easily extracted and the cost is less, then you can call it as a mine. A mine is only when it is easily and economically extracted the minerals. Ferrous minerals, as I just said, that they have content of iron, so we extract iron from them. So India is quite rich. India is quite rich as far as the ferrous minerals are concerned, especially the iron ore. So India is rich in iron ore deposits. In these ores, we have different types of variety like magnetite, like hematite. So let me just tell you that which kind of different type of iron ores we have. So iron ore is a basic mineral and it is actually the backbone of the industrial development, and it's fairly abundant in India. We find it in good quantity. So magnetite is the best, is the finest iron ore with very high content, that is 70% of the iron content. So it has a very good magnetic quality, magnetite. I'm talking about magnetite. Here it is. This is magnetite. So magnetite 70%, and it has very good magnetic quantities. That is why it is very much valuable to the electrical industry. And then we call it as hematite. Hematite ore is again most important industrial iron ore in terms of the quantities it is being used. So it is being used heavily. Slightly lower than iron content. This magnetite has around 50 to 60%. 50 to 60% of the iron content. Or the iron ore which we are talking about, they have certain belts. Belts means where they are generally found. So we have already identified the areas. I'll just go to these areas. These are iron ore fields. So this area, these are iron ore fields. And the triangle you see, these are the mines. These are the mines. So we have this one, this one, this one, and this one. 1, 2, 3, 4. So these are different belts being called. So first one is the Odisha Jharkhand belt. So this is the Odisha Jharkhand belt. We have Badamapar, Mayurbhanj, and Kendujhar, Singhbhum, the Naubundi, and Goa. These are the major mines here. Then we have this Durg Bastar Chandrapur, this area, Durg Bastar Chandrapur. So in Chhattisgarh and Maharashtra, high quality hematite, this which I was talking about. The high quality hematite ores, they are found that are exported to Japan and South Korea. Coming to this place, we have the Bellary, Chitradurga, Chikmagalur, Tumkur and Tumkur. Then in Karnataka, the Kundarmukh, this Kundarmukh mine is most important. It is 100% export unit. So all which is being mined, they are being exported. Then we have certain places in Maharashtra, Goa, this region also. And this, we have Ratnagiri mines. They have rich deposits for iron ore. Let me take you again to this place which we just talked about. So these are the iron ore fields which are being identified, and then we have iron ore mines as we just talked about, the Kendujhar, the Mayurbhanj, and Goa, and here we have the Chandrapur and other like this Ratnagiri, and we have the Bellary, Tumkur. All these are here. These are the places which we just discussed about. So this is the production of iron ore. The data is from 2003-04. So we have this the highest producing right now. At that time may be different, but at 2003-04 it was Karnataka, followed by Odisha, then Chhattisgarh, then Goa, Jharkhand, and then others. This is the iron ore. Now one more thing I need to tell you, there is something called as rat hole mining. So most of the minerals are under the control of, it is nationalized under the control of the government, Indian government. But in northeastern states, certain minerals are owned by certain individuals or sometimes communities. So if we talk about Meghalaya, there are large deposits of coal, iron ore, and limestone and dolomite. So they do the coal mining. So they make they do the coal mining in Jowal and Cherrapunji, and this is done by a family member. So they make a long narrow tunnel, and this is called as the rat hole. This is called as the rat hole mining. So we talked about this different belts here. Now coming to manganese. And this is manganese is generally used in the manufacturing, that is the vinirman, manufacturing of steel and ferromanganese alloy. Ferromanganese, let me write it just Mg, alloy. So for making 1 ton or 100 kg of steel, we required 10 kg of manganese. So manganese is used in manufacturing, steel, bleaching powder, insecticides, paints, and the largest producer of manganese is Odisha. So this is the distribution of manganese. Odisha 33%. This is again 2003-04, and we have Madhya Pradesh 22%, Karnataka around 15%, and others. So let me show you the areas which we are talking about. So this is the manganese. So these are the manganese areas. If you see, these are the manganese areas, and mostly, largest producer is Odisha. Now coming to non-ferrous minerals. So India is not very rich. We are not very satisfactory about the content, the non-ferrous minerals we have. So these minerals which include the copper, the bauxite, the lead, the zinc, and the gold, they play a very vital role in different metallurgical, engineering, and electrical industries. So let us see about the copper and bauxite. So copper, India again is deficient in copper. It's malleable, ductile, and it is having a good conduction of electricity. Because it is malleable, ductile, it is having a good conductor, you can say, properties. So they are used in, because of these properties, it is used in copper. This is tamba. It is used in electrical cables, electronics, and chemical industries. And what are the producers, or where are the producers? See, Balaghat, which is in Madhya Pradesh, it produces almost, highest 52% of India's copper. 52%. And there are other places also, like Singhbhumi in Jharkhand and Khetri in Rajasthan. Khetri in Rajasthan, these are also important copper producing areas. So this is the copper share. You see, Madhya Pradesh, because Balaghat almost produces 52%, so Madhya Pradesh is producing 58%, and followed by Rajasthan, it is producing 42%. Coming to bauxite. So this bauxite is known for that this is an ore from which aluminium is extracted. We extract aluminium. Now this aluminium has, why we are talking about aluminium? Because there is a clay-like substance which is called as alumina, and from there we extract aluminium. Now this aluminium has a very important property. It is an important metal, Al. Why? Because it has the strength of the iron, Fe. It has the strength of iron, but it is quite light. It is extremely light and having a very good conductivity. Means it is a good conductor and malleable also. As I just said, they are malleable. Like it is showing a very good property. So it's a good substitute of iron, you can say. So there is a production here, that is, they are found in Amarkantak Plateau, the Maikal Hills, and the Katni. And again, the largest producer is what? It's Odisha. 45% of total bauxite production is from Odisha only. Koraput in Odisha, it has the largest reserves of bauxite in the country, from which aluminium is extracted. So I'll just take you to the place where we find the bauxite. So these are the bauxite areas. Okay. The places, let me tell you again, the places are Amarkantak Plateau, Maikal Hills, and Katni. Coming to the non-metallic minerals, we start with mica, abrak. So these mica is made by series of plates, different plates. So it's split into thin sheets. It can be black, means the color can be different, black, green, red, yellow, or brown in color, and it has a very good dielectric strength. It's an electrical property, and it has low power loss value. So it loses power less, and it has a good insulation property. That is, it is resisting. It is a very good resistance to the high voltage, and it is used in electric and electronic industry. This is mica. So let me show you the places, that is Kodama, Gaya, Hazaribagh in Jharkhand, Ajmer, Rajasthan, Nellore, Andhra Pradesh. Here the mica is found. So here is mica, the star, this Nellore we just talked about, Gaya, Hazaribagh. So these are the places, and the Ajmer and this Bejwar area. These are the good producers of, or we find mica here. When we talk about rock minerals, we talk about limestone. So limestone, it is found in calcium carbonate sedimentary rocks and also in magnesium carbonate, calcium carbonate, calcium and magnesium carbonates. It is found there in association with the rocks composed of all these. So it is found in sedimentary rocks. Limestone is the basic raw material for the cement industry. Basically it is used in cement industry for iron smelting, iron praglan, loha praglan. So it is an essential element for the smelting iron ore in the blast furnace. And the largest producers are Andhra Pradesh, Madhya Pradesh and Rajasthan. The largest producers are Andhra Pradesh, Madhya Pradesh and Rajasthan. Hazards of mining, because in India we have various mines and people are working there. So they are facing some problems and there are hazards. You can say the hazards comes with this mining, like the pulmonary diseases caused by dust and obnoxious fumes from mines. This affects the health of the miners and the people who are involved in this industry. Inundation, that is the water coming inside or flooding inside, and the fires in mines and collapsing of the mines' roofs sometimes pose a serious threat to miners' lives. And mining contaminates the nearby water sources also, owing to dumping of the waste and slurry. And the land degradation is caused as land is dug quite deep for mining, and this makes it unsuitable for any further use after the mining site is abandoned. So we really require the conservation of minerals. Only 1% of the minerals, only 1% of the earth crust is of minerals. That is, if you take a globe, say it is 100% earth crust, only 1% is the minerals. So the way we are utilizing it, we need to do something for the conservation of minerals. So conservation of mineral is quite necessary. Actually, it's not necessary. It's now indispensable. You have to do it. It is necessary because mineral formation, the speed, the pace of mineral formation takes a lot of time, millions of years. That is, it is an extremely slow process, gradual process. So the rate of consumption that we have should not overshoot, should not overgo, should not overpace the rate of replenishment. Only 1% of the total mineral deposits are accessible. There may be more, but they are not physically or economically accessible or viable. Minerals are limited resources. We can count it. The number are countable, and eventually they will get exhausted if not used judicially and not used in a sustainable manner. Now coming to the conventional sources of energy, because we can classify the energy resources into two parts. That is, conventional energy resources and non-conventional energy resources. So conventional energy resources, we have been using it for long. That is, for example, if I take an example of firewood, then we have cattle dung. Let me write it cattle D. Then we have the coal, the petroleum. Then we have natural gas. And of course, the electricity, both in the hydel form as well as in the other form, which is thermal. These all are being used as conventional sources of energy. But because we just learned that why we need the conservation of the minerals, etc., and the conservation of energy has to be there, because most of the energy which comes from to the developing economy comes from these. So there has to be some other way. So we have non-conventional sources of energy, and this includes, let me write non-conventional energy resources. So this includes the solar energy, that is the sun's energy, then wind, of course, some areas get really nice wind. Then we have tidal energy, we have a long sea coastline, then geothermal, this we have, and then we have biogas, and of course the atomic energy. So these are the non-conventional source of energy. If you see that in the rural area, this upla, that is gobar cattle dung, this is used mostly for cooking, and this one type of a meal is made by a woman. She takes 100 number of cigarette, the smoke she takes. So we need to discourage this cow dung cake kind of these resources, energy way of producing things is not good. And also when you are making it, you are consuming or you are depleting the good thing, or called as manure, that can be used for the agriculture. So let us talk about these conventional sources of energy. Let me show you before that. This is a view of inside of a coal mine. So this situation is not very good, and people working here are facing a lot of health hazards. This is a view from outside of a coal mine. How does it look? This is inside. Now coming to coal, this is the most abundant fossil fuel available in India. So how this coal is made? It is made by the plants and trees which might have buried, plants and trees buried long back. They might have died, or they might have lived their life, and then we have soil on this. So here they face the temperature, the pressure, the compression, etc. And finally in million years they convert to coal. So there are certain types of coal we have, like the lignite, bituminous, and anthracite. So what are these? These are different types of variety of coal we get. So lignite, this is a low grade brown coal. It is soft, it has high moisture, that is water content, and it is found in various places. We have one example, Neyveli in Tamil Nadu. Then we have bituminous, most popular used coal this is, and this is used in smelting iron in a blast furnaces. Then we have anthracite. This is a high quality coal, very good type of coal. And these are found, as I said, the anthracite are found in Damodar Valley, West Bengal, Jharkhand, Jharia, Raniganj, Bokaro. These are important coal fields. And this coal is also found in the northern eastern state like Meghalaya, Assam, Arunachal Pradesh, etc. I will take you to the places where we'll find them. And then we coming to the another source of energy, which is petroleum. Petroleum, this is found in the rocks of tertiary age. That is, again, it takes a lot of time to be made, and 63% of the petroleum which we know in Indian region comes from 63% comes from Mumbai High. It's an offshore. It's an offshore that is inside the sea. It's a place where the oil is being dug, petroleum. 18% from Gujarat's Ankleshwar oil field, and 16% from Assam's Digboi, Naharkatia, Moram, Hogrijan oil fields. So Digboi in Assam is the oldest oil field of India. So mostly wherever we get this petroleum, we always get the natural gas. Natural gas is the gaseous form, always, generally, I must not say always, but generally found above petroleum. Wherever we have the content petroleum available, then natural gas can be there. So first natural gas is extracted. So environment friendly owing to low carbon dioxide emissions. Natural gas produces less carbon dioxide emissions, and as we know, CO2 is the gas responsible for the global warming. So whichever fuel is producing less carbon dioxide, it is good for us. So if you compress this natural gas, it becomes CNG, compressed natural gas, and this can be used in vehicles, as we see in various big cities. CNG is being employed, especially in Delhi. And this natural gas is found in Krishna Godavari Basin, Gulf of Cambay, Andaman and Nicobar Islands, and Mumbai High. And they are transported through pipelines from where they are produced. For example, Hazira, Vijaypur, Jagdishpur. This is called as HVJ line. And this is the longest, around 1700 kilometer pipeline that transports gas from Mumbai High to Basin. And there are various other routes it's follow. I'll just show you. But before that, we have electricity. Now, electricity can be made in different way. That is, we are using electricity and we are producing it in a turbine also, or by using the water. Water has a MGH, that is potential energy when it is on the height. When it comes down, it gains kinetic energy, and the turbines can be moved, and then with the electromagnetic induction, the current can be produced, electricity can be produced. So this is the one way which we use it. And the second is we use the coal, etc., coal and other fuel to produce electricity, coal, petroleum, natural gas. So this when we use, and we call it as a thermal power, that is by burning the fuels like the coal, like the petroleum and the natural gas. If we drive turbines, this is through water, but if we use these coal, petroleum and natural gas to drive turbines to produce thermal power now. So this is called thermal power, but the electricity remains the same. So electricity, we have hydroelectricity. This is done by the force of water that I just showed. Bhakra, Nangal, Damodar Valley projects, they generate hydroelectricity. Also we have the Kopili Hydel project, that is Kopili hydro projects, and they produce hydroelectric power. And the thermal electricity, that is we burn these coal, petroleum, natural gas in order to produce electricity. This is by coal, petroleum and natural gas, and there are around 310 thermal power plants in India. But the problem is they use these non-renewable fossil fuels to generate electricity. So these are the places which we need to understand, that where we find the coal, where we find the coal mines. So let me show you this area. These are the area of coal fields. These are the area of coal fields, and this is the Gondwana land. This is the tertiary land, and these coal is around 200 million years ago back. The life of this coal we find here, and the coal we find here is around 55 lakh years back. So these are the coal fields, but we have this triangle shows that we have coal mines like Singrauli, Korba, Singreni, Talcher, Bokaro, Jharia, and also here in these places. Then we have oil fields. So these are the oil fields. We have Basin and Mumbai High. Then we have here also at the Ankleshwar place, and from here, let me show you here also. There are places here where we find the Diboi, etc. These are the oil fields. But let me show you this 1700 kilometer HVJ line. This line goes here. See, it goes here, and it has various you can say tributaries also, and it goes up to this point. So this is how the content or can be transferred. So this line is HVJ natural gas pipeline. So this natural gas goes here, and we have major natural gas reserves in this place, here, and here also we have gas. See, this the lower part of northern eastern state. Then also we know that these are the major natural gas reserves. So these are in reserve, so we'll be using it. Then coming to the nuclear and thermal, I will be talking about nuclear just now, but let me show you this triangle. So because you have to remember this name, this is coming just now. This is Kakrapara. Then we have Tarapur, Kaiga, Kalapakkam, and we'll talk about others also. This Narora. These are all the nuclear power plants. Then we have so many thermal power plants where we burn the coal, petroleum and natural gas in order to produce the electricity. And if you know this, Kalpakkam is indigenous. Others are with the help of French, Americans, etc. This nuclear power plants has been made. So that's what I was talking about. This is nuclear energy. So this is obtained from the nuclear fission of radioactive elements like uranium and thorium. So the nuclear, there are two reactions which gives us immense amount of the energy, which is nuclear fission and nuclear fusion. So nuclear fission in the controlled environment can be used to produce electricity, or you can say power. So we use uranium and thorium for that. So uranium and thorium, they are found in Jharkhand, Rajasthan, and Kerala. And then India has 6 nuclear power stations. We just saw some of these in the map. Rawat Bhata in Rajasthan, Narora in Uttar Pradesh, Kalpakkam in Tamil Nadu, Tarapur in Maharashtra, Kaiga in Karnataka, Kagrapara in Gujarat. So these are the various important power stations. So there are, as I said, that uranium and thorium, we find it in different places. So these are the places we just saw, Jharkhand, and we have this in Rajasthan. It is found in the Aravalli ranges, and in Kerala also we have monazite sand, monazite, monazite. This monazite sand in Kerala, there also we find rich number, means we find good value of thorium. So now coming to the India, which is we have a very good solar energy because the latitude in which we are located. So India is a tropical country and we have enormous potential for solar power. So solar energy can be converted into electrical energy, that is the solar energy can be easily converted into electricity using the photovoltaic technology, that is photovoltaic, converting photo or the thermal energy into the electricity. So largest solar plant in India is at Madhapur. Please understand, largest solar plant in India is at Madhapur, Gujarat, and maximum potential is, because the region will get heavy thermal energy, or you can say sun's infrared energy, you can say Rajasthan and Gujarat. So we have many possibilities here. Even before that, people are using the solar cooker, etc., solar cells, and the solar lights. They have been using it. So this is an example of a solar operated electronic milk testing equipment. This is just to show how this solar energy can be harnessed and they can be employed. Coming to the wind power, we have again very good wind, that is anything which is 10 kilometer wind flowing 10 kilometer plus, 10 kilometer an hour plus, then wind power can be harnessed, it can be used. So India is a wind superpower. We are wind superpower. Actually, we are 5th in this place if you take all the world. So the largest wind farm cluster, if you see here, this is an example showing this. This is a wind, wherever we have this windmill, like a fan it is, wherever it is installed, it is called cluster. It is called farm. It is called farm. So we have largest wind farm cluster in Tamil Nadu, and this has variation, or you can say belt from Nagarcoil to Madurai. So you see there, this is the range where these are installed. And apart from this, you get it in Andhra Pradesh and Maharashtra, Gujarat, Kerala. They also have a very huge potential for tapping the wind energy. So the Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra, Lakshadweep, they also have wind farms. And this, as I said, Nagarcoil and Jaisalmer, they are also well known for its effective wind energy harnessing. Now coming to the biogas. See, this biogas, this is a biogas plant, as you see. The biogas, is produced from the waste, farm waste, animal waste, human waste. And this is quite effective than firewood, dung cakes and kerosene. And you don't have to do anything. Just put the waste material here and the microorganisms and the various processes will automatically gives you a very clean fuel that is called biogas. So used mainly for domestic consumption in rural areas. So many people you will see gobar gas plants. So gobar gas plants, they are set up in rural areas which decompose organic waste and produce gas as well as provide manure. Once the gas is being produced, the content which is left, that is the slurry, this slurry can be used in the agriculture field as manure. Then one more important thing is of energy, which is the non-conventional energy source, is tidal energy. Now this tidal energy is because of the tide, low tide, high tide. So these tides are mainly because of the sun's motion. So whenever this can be harnessed, that is energy of the oceanic tides is used for producing electricity. It can be used. So Gulf of Kutch has a great potential for tidal energy. So all the Gulf, actually whatever khadi we have, khadi or Gulf, these are the places where it can be employed. For example, how does this happens? I'll just tell you about Gulf of Kutch. There is a 900 megawatt tidal energy power plant is set up here by the National Hydropower Corporation. Megawatt. See, just because they want to use the tidal energy. So how does this happen? The water is coming in the high tide, so there are gates, and this goes inside, so the gates are closed. So when they come out, there is a pipe, and there is a very pipe, and there is a speed which this water comes back because of the flow. So here the turbines are placed, and these turbines are moved, and this is how tidal energy can be harnessed. Then one more important energy is geothermal energy. So this geothermal energy, it is the energy, if you see the earth crust, this, if you go inside, we cannot go inside, but it is very hot. Even it is so hot in the crust that you see when the volcano erupts, it gives you molten lava. So it's so heated up here. So there are places near the earth crust which are quite heated, or they have the energy, and this is called the geothermal energy. So it is the energy produced by using internal heat of the earth. The hot springs in India, they are very ideal source for the generation of geothermal energy. So Manikaran in the Himachal Pradesh and Puga Valley in Ladakh, they have geothermal power projects. So now the important thing is conservation of energy, because energy saved is energy produced. We must see that all these things which are going on, we are utilizing various energy resources that are going to finish in due course of time, and the way the population is increasing, it will finish in no time. So we have to go, the future is the non-conventional source of energy, and the source of energy conventional has to be used judiciously and in a sustainable manner, so that the offspring, the people who are coming after us, they also get some energy for their living. Thank you so much. Take care of yourself.